Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. And in this video, we are going to be talking about the uniform probability distribution. Okay, now we're changing gears here. The probability distributions we talked about before were discrete probability distributions, and now we are about to start talking about continuous probability distribution. So just a reminder, discrete means that there are a countable number of outcomes. Continuous means there are infinitely many possible outcomes, okay? And so, what is a uniform probability distribution? This is a type of continuous probability distribution in which all of the outcomes are equally likely, meaning that all of the outcomes have the same probability, okay? This is an example of a model or a graph of a uniform probability distribution. In this case, there are infinitely many outcomes, but it can be between 0 and 10. And remember, with discrete, it's only the whole numbers in between there, but with continuous, you can have the whole numbers plus any decimals in between those whole numbers. So in this example of this graph of this uniform probability distribution, it ranges from 0 to 10, and the probability of all of these possible outcomes is 1/10. All right, this is an example. All right. Now, a probability density function, PDF, is an equation used to compute probabilities of continuous random variables, and it must satisfy these two properties, okay? One, the total area under the curve over all possible values of the random variable must equal 1. And basically, I'll show you how to find the area under the curve in a moment, but that area has to equal 1. And 2, the height of the graph of the equation must be greater than or equal to 0 for all possible values of the random variable. So this axis here, P of X, represents the probability. And remember, your probability has to be between 0 and 1. And so this second one is saying that the height should be bigger than 0 because the probability should be bigger than 0. Well, the probability could also equal 0, but for this one, it needs to be bigger than 0 because the sum of the probabilities has to be 1, remember? And so how would you find the area of this? So for number 1, property number 1, it says the total area under the graph of the equation over all possible random values must equal 1. So in order to find the area of this rectangle here, the area of the inside, I would do the length times the width. And in this case, this is this length here is 10. You could do 10 minus 0, so 10. And the probability here is 1/10. And if you do 10 times 1/10, that equals 1. That gives you the area of this rectangle right here. And so that must be true for every probability density function. The area under the graph must equal 1. All right, and here's just another recap to let you know how important it is. The area under the graph of the density function over an interval represents the probability of observing a value of the random variable in that interval. So that area underneath the graph represents the probability, okay? And that area has to be 1. And here is another example of a uniform distribution in general. And it's going to go over some interval from A to B. And the way you will find your probability is by doing 1 divided by this length right here from A to B. So B minus A. So 1 over B minus A will help you find your probability. So here's an example. Imagine that a friend of yours is always late. Let the random variable X represent the time from when you are supposed to meet your friend until he shows up. You might be that person. It might not be your friend. But just imagine it's a friend right now. So suppose your friend could be on time. That means X equals 0. Or up to 30 minutes late. That means X equals 30. So X represents how late they are. With all equal intervals of time between 0 and 30 being equally likely. So the chance of that friend making it between 0 and 30 minutes late is the probability is the same for every time frame in that interval. So for example, your friend is just as likely to be 3 to 4 minutes late as he is to be 25 to 26 minutes late. The random variable X can be any value in the interval from 0 to 30. That is, X is between 0 and 30, okay? So a probability distribution for this would look like this. So your interval will go from 0 to 30. And then your probability will be 1 over 30. Again, how did we calculate that? We did 1 over b minus a. And in this case, that's 1 over 30 minus 0. That should be a 0, not a 3, which equals to 1 over 30. And that's how you get this probability right here. And if you was to multiply 1 over 30 times the length of this interval, which is 30, you end up with the 1. And using this formula, the 1 over b minus a, to find this probability over here will give you that area of 1 all the time. So what is the probability that your friend will be between 10 and 20 minutes late? So I've redrawn that. This is that probability distribution. But now I'm only interested in the area between 10 and 20 minutes late. Remember, the area under the curve represents the probability. So I need to know what is the area under this curve. So in order to find the area under that curve, I need to know this distance. Hold on, y'all. It's zoomed in. Okay, I need to know this distance here, which is 20 minus 10, which is 10. And I would do it times the probability. So it will be 10 times 1 over 30, which equals to 10 over 30, which reduces to 1/3, which is a decimal. That's approximately 0.333 repeating. So the probability that your friend will be 10 to 20 minutes late is 0.333 repeating, or that's about a 33.3% chance that your friend is going to be 10 to 20 minutes late. All right, it is 10 a.m. There is a 20% probability your friend will arrive within the next blank minutes. We need to figure out how many minutes it will be if there's a 20% chance, right? So what we have here is we have a region that's highlighted, and it goes to some number, which we don't know. That's what we have to find, is what number does it go to. So it goes to some number x naught here. And the area is 0.2. Where did that 0.2 come from? It came from this 20%. If you transfer that to a decimal, that is 0.20. So the probability is 0.20. So we need to know, remember, to find the probability, you do that distance here, which that distance is going to be x naught, because it's x naught minus 0, times the probability, which is 1 over 30. So if we want to solve for x naught, so technically it's x naught minus 0, but x naught minus 0 is x naught. So it's 0.20 x naught times 1 over 30. If we want to solve for x naught, then we'll multiply both sides by 30, because you got to get rid of the 1 over 30. And since that's 1 divided by 30, you multiply both sides by 30 to make those 30s cancel. And so 30 times 0.2 is 6. So your x naught ends up equaling 6. So within the next 6 minutes. So there is a 20% probability your friend will arrive within the next 6 minutes. Now this 10 a.m., that was just what we call extra information to throw you off. But what we needed was the probability and the 20% probability. And we also needed the 1 over 30 probability. All right. Let me know if you have any questions. If not, I'm going to keep on rolling. All right, and the last part is find the probability that your friend is no more than 5 minutes late. Now, I don't have a model for this, but I'm going to kind of sketch that model back out. So it was from 0 to 30. This was 0, this was 30, and my probability was 1 over 30. And let's just say 5 is right here. I want to find the probability that your friend is no more than 5 minutes late. So no more than means it's less than. So it's going to be less than 5. So I want to know what is this area right here. Okay. So to find that area, I need this distance here, which is going to be 5 because it's 5 minus 0. And I'll just write that on there so you can know. Times the 1 over 30 probability. So that gives me 5 times 1 over 30. Which is equal to 5 over 30, which reduces to 1 over 6, which is approximately 0.167. So if you round it to 3 decimal places, it's 0.16666 repeating, but it's 0.167 if you round it to 3 decimal places, which means there's about a 16% chance, 16.7% chance that the friend will be no more than 5 minutes late. All right. So this is a uniform probability distribution. It means that all of the possibilities within the time frame for your variable, or within every possible outcome of your variable, has the same probability. The probability is the same, and therefore that's why we have this flat graph right here. Alrighty. If you have any questions about the uniform probability distribution, please don't hesitate to ask. Thank you for watching, and I will see you in the next video.